So our company is called PlanOpSim, and that stands for Planar Optics Simulation, because our core business is simulating this new field of planar optics. We saw there was a big problem in designing meta surfaces, which really would make it possible to make optical systems that are as small as the electronic chips that we all carry around. But the problem is these systems are very complicated to design. It takes a lot of time, they are hard to fabricate, and that was really holding back this innovation. To solve that, we created a software that simulates the different physical aspects on multiple scales on the cloud to allow for super fast design of new optical systems.
We see the immense untapped potential of meta optics or optical meta surfaces. It needs tooling to get things right, and this is our core focus with PlanOpSim.
Meta surfaces can really enter into all kinds of systems, smartphones, cars, and the people that need to design those, of course, need a design software. Our technology really benefits the R&D teams in research labs and design companies that are making new optical systems that are drastically better than the classical glass lenses that we all know.
PlanOpSim is in Belgium. We are a team of specialists in meta lenses and meta surfaces. So we create software and do design projects for various companies and universities to make meta lens design as easy as possible. We're doing that from our team in Belgium, and we were started in 2019. So we are a young company, but maybe not fully a startup anymore.
So you have been with Optica for already, I believe, more than 2 years. But what is new with you? What happened in the past year?
In the past year, we've developed many new features into our software. So we've created additional features to make it even more user-friendly. We can now automate meta surface designs through scripting via our SDK. We've released ODA and PDK kits to design larger meta surfaces and design them more accurately and more in line with what can be fabricated. And the crowning piece for this year's feature release was actually the release of our optimization toolkit that allows you to select the target of what your meta surface should do, and then uses various optimization algorithms to give you the best configuration.
Describe what these PDKs and tools that you have just released bring to the end customer, to the user. Why is it important?
The SDK and the PDK are ways to automate the meta surface design and to integrate it in a more close way with the manufacturing. So the PDK is a set of structures that is released and guaranteed by a manufacturer so that a designer can directly apply them and be sure that there is a commercially available process to manufacture these components so that it doesn't remain just a on paper or on computer design, but actually becomes a manufacturable piece. We can guarantee manufacturability of the meta surface, not just in small, let's say, R&D volumes, but also going to larger and larger volumes, larger and larger production batches. PlanOpSim applies a multi-scale calculation method, which separates the problem, which is a very large scale dynamic range problem going from nanostructures to large optical systems. We break that down in our multi-scale simulation method into various parts and apply the right method at the right scale. So for the nanostructures, we're using full wave design methods. But once we go to larger components, and that means, for instance, several millimeter or several centimeter size, the full wave methods are no longer applicable. And instead, wave optics methods are used. When we go then to centimeter meter scale optical systems like cameras or even telescopes, wave optics is also difficult to apply. And then we bridge that to ray tracing so that the tools that the optical designer is used to use can still be applied even with this new meta surface technology, which is fundamentally very different from classical refractive optics.
What is the added benefit of this type of the calculation or using this algorithm?
This algorithm is really the only way that we can do an end-to-end design of the meta surface. So we can go from the nanostructure to the component to the full system. And in order for any component to be useful, it always has to be embedded in a system. And this method allows you to do that. Whereas with other methods, you would have to stop and hope that it works. These features are very useful for anyone that's really involved in the meta surface community industry. So that goes from the designers to the manufacturers to researchers, also to people that are providing the raw material like substrates or the manufacturing equipment. for this technology of meta surfaces to become a large-scale applied technique, the whole ecosystem needs to form, and we see that it is forming, but the various players need to be interacting very tightly in order to really get to a large-scale application.
In this respect, then, I would like to ask you, you see that we all see that this field is increasing and growing, but maybe not at all, not the speed that we would like to. So what, in your view, are the roadblocks or, let's say, paramount challenges that prevent meta surfaces from increasing their deployment?
We see two main challenges. The first relates to design, and the other relates to manufacturing at large scale, and both actually have to be solved before meta surfaces can have a real breakthrough. When it comes to design, this is not yet there is not yet a widely accepted and solved way to design meta surfaces. We mentioned a little bit before already that we have the different scales of calculation. They need to be even better integrated and become even faster, even more accurate to get to real design applications in ever more complex systems. So if we think of a smartphone lens, for instance, there are 7 or more lenses typically in there that all need to be adjusted to each other. The design tools need to become even faster and even more accurate, even better at tolerancing to be able to really capture this opportunity. When it comes to the manufacturing, there's currently only very few players that really have the ability to manufacture in large volume and in a proven way meta surfaces. And also there, the design helps in making sure that the structures are robust to all fabrication deviations that happen during the process.
If we think, let's say, optimistically in another 10 years, how big do you think the meta surfaces can become?
That is the billion-dollar question, of course. So I am very bullish, let's say, on that aspect, because we are just scratching the surface of the applications of meta surfaces. If we see what people are doing right now with meta surfaces, we are replacing some conventional components with a better version using meta surfaces. But the real power of these of this technology lies in the fact that we can make things that did not exist before. And I think there is a very wide open field that is still to be explored in the next 10, 20 years. So I see this replacing lots of sensors, making them a lot more compact. I also see this making types of sensors that we did not envision before. For instance, combining pattern recognition directly in the hardware, in the optics.
Being a part of the Optica, you know, we're always interested and strive to enable useful relationships and partnerships for you. What type of the partners or partnerships in your state now you're searching for?
So for PlanOpSim, we are looking for partners in the application of meta surfaces. So people with application knowledge connected to end users, system integrators and system builders, as well as people doing the research, people doing the manufacturing. These we all feel are our partners. And this is also the role we see for ourselves. We see ourselves, PlanOpSim, as a catalyst in this field of meta surfaces to connect all the parties, make sure that we go the furthest possible in the shortest possible time.
What can Optica do for you?
What you are already doing, in fact, constantly connecting us with the people in the field, scouting for new opportunities, greasing these wheels to make sure that the optics field keeps well integrated with one another.